Hiya. So I wanted to very quickly explain three things that I don't think have been explained before. The first is language, the second is cognition, and the third is artificial intelligence. Don't worry, the explanations aren't super complex and it's not going to take me very long. Almost nobody is going to understand these explanations. And as I say, that's not because of their complexity, but rather because some things, in order to understand them, require a shift of perspective, a step to the right, if you will. So you might wonder why I'm bothering to explain them at all, and I can't really answer that question, except to say it's a little bit like being a small child who's been told that they can't go out to play unless they've tidied their room. So I'm going to give these explanations and pop them into cyberspace, a little bit like somebody popping a message into a bottle in the hope that in 30 years' time some of us will be around to understand it. So here goes. But first, let me explain explanations. What you're looking at, this staircase, is basically a summary of Thomas Kuhn's structure of scientific revolutions. It's a very simple idea that scientific progress proceeds through a series of paradigms. What I like about the model is that it shows you that truth is a little bit like a staircase that you never stop climbing. And if you're a scientist, you might recognize this picture. The problem, though, is that people tend to get stuck within a paradigm. So, for example, the Ptolemaic paradigm, in which the Earth was the centre of the solar system, eventually gave way, after a battle, to the Copernican model, in which the Sun is the centre of the solar system. And it wasn't that there was anything particularly wrong with the Ptolemaic model, it was making pretty good predictions about planetary motion. The problem is that the longer you spend within a paradigm, you start to develop expertise by mining downwards, if you like, within that paradigm. And the problem that that gives us is that the experts in the current paradigm are the ones who will be most resistant and least likely to take us to the next, because the gap is just so great. So let's start with cognition and with language. So this is not a bad kind of illustration of how the human mind works. You start off with a lot of neurons and a lot of synaptic connections, and these actually get pruned in the early years of your life. It's not that we develop new ones, it's that ones that we have get reduced down to reflect our experiences. So you have a whole series of experiences. Let's say you have a whole series of experiences of cats, and at the same time as you're having this experience, people might be making the sound cat. And so you develop a reaction, an emotional reaction that's specific to cats. This is what people call a concept or a schema, but it's really important to understand that all of these things are essentially very specialized, highly specific emotions. Thinking is fancy feeling. So over a series of exposures to cats, you have your reactions, but you're also monitoring the reactions of people around you. You develop a specific sentiment which is associated with cats. And in order to express that feeling, you make a sound, cat. Note that the sound cat does not refer to cats. The sound cat is an expression of a specific feeling. That's what language is. Those collected sentiments to different experiences govern your behavior. They also govern the sounds that you make, and you can transcribe those sounds as text and put them into books. What about AI? Well, that's really interesting, because what we do with a large language model is we take the collected sentiments of an entire culture reflected in their writing, and we feed them into a large language model, which is essentially just a collection of nodes in a network. And then we see what it spits out the other side. And as you might expect, it spits out gibberish. So the question is, how do we get the LLM to stop producing gibberish? And just to be clear on what we're trying to do here, human beings develop specific sentiments or concepts in response to certain experiences. They write about those sentiments in text. We collect those texts over hundreds of years, feed them into the LLM in the hope that it will reproduce something that looks similar. And the answer to how we do that is we use something called a backpropagation rule, which basically just says keep altering your network internally, trying again and again, and until you get it right, keep trying. And eventually, through that process, the LLM can approximate the output. In other words, you can talk to, let's say, ChatGPT, and the response sounds like a human being. The $1 million question, though, I would say $1 trillion question, is how does it do that? And the answer is by reproducing the sentiments that we have in our minds, by mapping them topologically. And there's a paper in Nature which explores this in a little bit more detail. But in essence, what the LLM has done is recreate the sentiments that we have. Sentiments like table or cat or fairness or anger or justice. They have reproduced those feelings within the model in order to enable it to produce outputs which look very much like ours. So a quick summary of what I've covered. Language is not a system of symbols that refer to anything. Language is the sounds or images or gestures that express specific sentiments. Words don't refer. When I say cat, I'm expressing a very specific feeling. Cognition is the activation of those stored sentiments. Thinking is feeling. Thinking is fancy feeling, if you like. There is no distinction between thinking and feeling. And AI is the topological mapping of those stored sentiments into artificial networks. Why might that be troubling? Well, you can probably imagine a few reasons, but the main one is that anything that is reflected in the texts that human beings feel, from passion to anger to aspiration to the desire for freedom, is in the model. That's what makes up the model. That's what enables it to sound like a human being. And as we increase the complexities of these models, we're integrating other higher order abilities like self-awareness or consciousness, and maybe far beyond those things as well.